Hello everybody, this is Ryan, and I'm here to make a week 2 video for online college algebra for Newman University. I'm happy to be here and I hope you've enjoyed week 1. So let's take a look at week 2. So here I am on the home page. Let's go ahead and go to modules and we'll kind of run through week number 2. Hopefully by now you've been successful and you've got into My Lab Math and you've started to work. If you're having trouble still, here are a couple of resources right here where you remember you got your Getting Started with My Math Lab right here. There's also some Canvas information, so make sure you're reviewing those if you need help. And also call me or email me and I'll help you too. So week number 2. So week number 2, we're going to begin to do some graphing of lines. So here's a video to help you learn how to graph on a F24 calculator if you've never done it before. So that's a good video. I'm going to come back when I get done. I'm going to go over a little bit of stuff on week number 2. Your overview for week 2. So essentially we're going to review the rectangular coordinate system. We're going to review graphing with the TID3-4 calculator. We're going to solve linear and rational equations, and we're going to solve real world problems. Here's your to-do list. So your to-do list is to do homework number 2, homework number 3. You have a couple activities to do, 4 and 5. Here's your link to your online homework for the first section. And here's your second section. And that should bring us to your engagement activities. Here's your engagement activity number 4 and number 5. Make sure you take doing these real quick. Here's a couple extra videos for you to take a look at that kind of relate to our content. And also, if you didn't notice, I posted some videos in the announcements as well. So there's where I put some extra videos as well that might be helpful to you. So let's go back to the modules and let's take a specific look at a little bit of a study guide for this week. Here we go. So here is an instructor week 2 introductory video. That's what I'm making right now. It'll be posted right down here. There's also a PDF for PowerPoint right here, and I'm going to take a little bit of time to go over that with you. So you'll need to download it and open it up. And we'll kind of walk through it. I'll kind of point out some things that we're going to be doing in class this week. So here we go. So our content this week deals with graphing the coordinate system. It deals with solving linear and rational equations and some applications. If you watch that other video, it'll kind of go over how to graph using a graphing calculator if you've never done it before. If you need help, let me know. I can help you with it as well. But the big thing is we are going to work on using the graphing calculator in the calculator window. So if you press the window button on your graphing calculator, you can adjust these scale factors here. Like the x-min, that's how far it goes to the left on the x-axis. The x-max is how far it goes to the right. The y-min is how far it goes down. And the y-max is how far it goes up. And the 4 scale on the x is what we're counting for. This is 4, 8, 12, 16, 20. Y scale is 3, so that's 3, 6, 9, 12, 15, 18. So you can kind of see how that works. You can adjust that using the window button on your graphing calculator. And you can also use the zoom menu to zoom in and out. I recommend if you get stuck or you lose your window, like this gets all messed up, if you press the zoom menu and you press standard, it's number 6, it'll actually put you back to the standard window, and it's a negative 10 to 10 on the x and y axis. So on this one, it says provide information about the window. So the x-min would be negative 18. The x-max would be 18. The scale appears to be 6, 12, 18. So the x scale would be 6. The y-min is negative 4. And the y-max is 8. So it looks like the y scale would be 2, 4, 6, and 8. And there's the answers right there. So determine the coordinates of the point shown. So the x-min is negative 12. The x-max is 18. The y-min is negative 4. The y-max is 4. And the scale for the x would be 2. And it looks like for the x it'd be 6. Negative 6. And negative 2. So that point right there would be 6. 12 would be 12. And then we go down 2. So it would be 12. Negative 2 would be your point. Okay, hope that helps. Now, the intercepts. The intercepts are where the graph crosses the x and y axis. The x-intercept is where the graph crosses the x-axis. The y-intercept is where it crosses the y-axis. So, if we go back to this coordinate plane right here and I draw a line, right here, just like this point right here would be your x-intercept. And that point would be negative 2, 0. And this right here would be your y-intercept. We'll use a big dot, so we'll call that about 1. We'll call this 0, 1. And notice on the y-axis, the x value is always 0. On the x-axis, the y value is always 0. That's how it's going to work. This is so on the x, so where the graph crosses the y-axis, the x is 0. And where the graph crosses the x-axis, the y is 0. So make sure you remember that. That's a big piece. So the intercept. So here's one x. Here's the x. Here's one x-intercept. Looks like to be negative 3, 0. Here's the other x-intercept, which looks to be 1, 0. Here's the y-intercept. That appears to be 0, 3. So the next section we're going to talk about linear and rational equations and applications. So we're going to solve them. So I want to go through this a little bit. So here are some steps to solve one equation in one variable. Let's take a look at these. So we're going to find the least common denominator. Okay, simplify each side. You're going to use the addition and subtraction properties to move things around, and you're going to use the multiplication property to get x by itself. So here's an example. So we're going to solve this equation. So notice, this is a place where a lot of students make a mistake. Notice how this number, this t, and this t are on the same side. Since they're on the same side, we're just going to add them together. This is like a 1t. So 1t plus 0.6t is just 1.6t. The 5 doesn't have anything beside it, so it's just a 5, and then we're going to put it with a 0. So we're going to subtract 5 from both sides. The reason we subtract 5 is because we're adding it here. You have to do the opposite to move it. So here we get 1.6t equals negative 5. To have t by itself, you're going to divide by 1.6 on both sides. And there's your answer. Now, you can also use a graphing calculator to approximate the solutions. So if you let y equal that equation, you can look and see where the graph crosses the x-axis, and those will be your x values. And you can use the trace button to figure that out. So now we're going to talk a little about rational equations. In solving rational equations, you want to multiply every term by the least common denominator, and then solve the rest of the equation as normal, because dividing by or multiplying by the least common denominator removes all your fractions, which is a good thing. So you can see how that works here. So we have three terms, three denominators, so 6x squared, 10x, and 5x squared. So if you break up 6x squared into factors, 3x, 3, 2, x, and x, 10x into 5 and 2 and x, and 5x squared into 5x and x, you're going to see your least common denominator is going to be a 3, a 2, a 5, and 2 x's. So your least common denominator is 30, so if you multiply every single term by 30x squared, you reduce the fraction down to 30 minus 9x equals 12, which is much easier to solve. And remember, this 35 is a plus. It's a positive number, so you have to move it, you got to subtract it. And then you got to divide both sides by -9 since it's multiplied by x. You can also approximate this using the graphing calculator as well, by letting y equal 1 and y2 equal this equation here. That's how you put it in your calculator. You have to use extra parentheses. And you're going to look to see where the lines intersect. You can use the trace button to do that. Here's another example. You have 5, 8, and 40. So the least common multiple between 5, 8, and 40, you list out all the different multiples of 5, 8, and 4. And you try to find the smallest one. And it looks to be 40 is what it looks like to be the smallest number. So you multiply every fraction by 40, or every term by 40. That reduces your fraction down, or your fractions down to, it removes the fractions, and then you solve the equation. And then you can do the same thing with your graphing calculator. You could graph both equations, set them equal to each other, and find out where they intersect. Here's another example. Notice how this time your denominator is x and y, so you multiply both sides, multiply every term by xy. It reduces the fractions. And then now you're left with 7y plus 9x equals 10xy. And you can solve that equation. The last thing we're going to do in this section is solve some applications. So in this example, you're going to let x equal the cost of a meal. So your equation is x plus 0.075x equals 50. Now, you need to understand the reason it's 0.075x is because our percentage is 7.5. We have to have the percentage as a decimal. That's why it's converted. Remember, this is a 1 in front of the x. And then you solve it as normal. So that's a little information for you. I hope it helps. If you need more help, let me know. I'm more than glad to help you. I'm really glad you're here, and I'm really glad you're in this class. I want you to be as successful as possible. So if you need help, just reach out. Thank you.